Hello, my name is Chris Burton and my presentation is on the effect of Escherichia coli on the species Ailuropoda melanoleuca. But what is Ailuropoda melanoleuca? It's a giant panda.
Oh, look at the giant panda. He's so cute. Look at those guys. They're like cuddling with one another. Oh my god, I just want to take one home.
These guys are in serious danger of becoming extinct. There are currently less than 2,000 pandas left in the wild, and they are facing numerous challenges to their survival as a species. Chief among them is deforestation. Because of deforestation, pandas have significantly lost a large portion of their natural habitat. Look at that poor panda. He is so sad. This is a map of the area that pandas inhabit. The orange is the area that pandas were able to live free in just 200 years ago. The red portion is what they live in today. I didn't do a size comparison to find out the exact difference between the two, but I'm going to go out on a limb and say that the red area is significantly smaller than that of the orange area. There are, of course, other dangers that pose a high risk to panda survival as well.
Poachers!
These guys are awful people. Truly awful people. And do you know why they do it? Halloween costumes. I mean, yes, she is adorable. But does that really constitute the killing of an entire species just to dress up a little girl to go trick-or-treating? My answer is no, it is not. Now that we have identified some of the critical risks that pandas are facing, we can key in to yet another danger the giant panda faces in its everyday life. E. coli. Now you might have been told by your biology instructor that E. coli forms a symbiotic, mutualistic relationship with its host. And she would be correct. But not all E. coli is the same. Some are parasitic, and others form a commensalistic relationship with their hosts. In fact, there are 190 different species or serotypes of E. coli. It is important to know what different types of E. coli are present in the panda population, which ones have antibiotic-resistant genes, and what antibiotics they are susceptible to so that proper medication can be given to the pandas without increasing the risk of creating a superbacteria that is resistant to many or possibly all of the antibiotics that we currently have at our disposal. To do this, researchers gathered fecal matter from panda droppings and collected vaginal secretions from female pandas when they were in drug-induced sleep. Because seriously, how else would you collect vaginal secretions from a bear? Yes, it's cute, but it's still a bear. Can you guess how many different strains of E. coli they found in the panda population? Wow. Yeah, good guess. Yes, there were 97 different species of E. coli found by the researchers. These were classified into different serogroups based on O-type. O-type is a type of antigen found on the surface of bacteria. This table shows that some serotypes are found predominantly in either the gastrointestinal tract or the vaginal region. P-value is a statistical measurement to determine significant values for this study. And for it, the p-value was set to less than 0.05. Now, if you don't understand this, don't worry. I took statistics, and I don't understand where they came up with some of their p-value numbers. But I'm going to take the data to be true, and so should you. You can see that the O-types, 4 and 18, are much more prevalent in the vaginal samples than in the fecal, while isolates classified as others and NT are much more prevalent in the fecal matter and not the vaginal secretions. Notice that the O-type 158 has only isolates from fecal matter and none from vaginal secretions. Now to me, that screams to be a significant value, but apparently not according to my source. This table shows how many isolates contain certain genes that code for antibiotic resistance. You can see how the strains of E. coli differ greatly when it comes to genetic variants. This is going to have a particular effect on which and how many various antibiotics they are resistant to. Again, how is it possible to have isolates from fecal matter containing the IPAH and AGGR virulence factors, but none from the vaginal secretions without having it be considered to be significant is beyond me. All I will say is that there is an important, noteworthy, momentous, or perhaps even substantial difference between these two data sets. Shout out to the thesaurus. In this table, we can see that the 97 isolates were able to be categorized into 4 main phylogenetic groups. There was a significant difference in number of isolates from groups B1, B2, and D, with B1 having more fecal isolates than vaginal, and B2 and D having more vaginal isolates than fecal. In this table, we can see the results from testing all the isolates against various antibiotics. 13 antibiotics were tested in total. These included ampicillin, erythromycin, tetracycline, and many more that I'm not even going to try to pronounce. Notice from the data that none of these antibiotics is suitable against all of the various isolates of E. coli. Amoxicillin clavulanic acid, denoted AMC, and ciprofloxacin, denoted CIP, were much more successful at treating the isolates than the rest of the antibiotics. Some of the antibiotics were better suited to treating the strains of E. coli found in the vaginal secretions than in the fecal matter. Specifically, the antibiotics denoted as AMI, FOX, CPZ, AXO, and KAN were much more effective against the isolates from vaginal secretions than their fecal counterparts. So what is the takeaway from this? The researchers concluded that based on this information, a varied and rotating antibiotic regimen should be implemented. This will allow an infected panda to get healthy without creating even more resistant strains of E. coli. Also, quit dressing your kids up in panda skins. It's enough, okay? Just stop. This concludes my presentation. Thank you very much.